Here's what I hope that you learned from that activity. So, a large proportion of the CO2 emitted since the Industrial Revolution, about 25%, has been dissolved in seawater. The open ocean water pH has fallen. It's not acidic on the pH scale, but it has trended towards the acidic side. It's fallen from 8.2 in 1750 to 8.1 in the year 2000. It's continuing to decrease. And this doesn't seem like a whole lot, but pH is on a log scale. So this is actually about a 30% increase in acidity. And ocean acidification is concerning to ocean life because it eats away at the shells of marine organisms. Very small organisms like larvae and phytoplankton are most at risk. Interestingly, in recent years, we've discovered that acidification also changes the ways that organisms interact because it changes their behavior. It makes them take more risks, and it makes them lazy in some cases. And so I wanted to show you a little bit of information from my own work about how acidification can impact behavior. So this is a study that I did a few years back where I acidified soft-shell clams, which are a relatively large clam. They grow to be about the size of your hand. These ones were younger, so they were probably about an inch or two in shell height. I put them in these tanks and bubbled in some CO2 and acidified them. I also had some controls that were not acidified. And after some time, I exposed these clams to a predator, the blue crab, in acidified and non-acidified conditions. So this is a picture of a blue crab right here. And so these were my experimental tanks, and my CO2 was bubbled from this canister here, and the amount of CO2 entering the water was controlled to achieve these pH ranges. So 7.0 to 7.2 is my acidified. This is more realistic for an acidified coastal condition because the pH in coastal areas tends to be lower. And so I acidified these for 4 weeks and gave the crabs a 5-day acclimation period to get them used to the acidified water. And I measured for the clams' shell length, mortality, biomass, and the weight of their shell. And I measured clam behavior through a simulated predator approach. I'll show you that in the next slide. And predator-prey interactions through the predator behavior. I took video of the predator and watched how much time it spent eating. And so for clam behavior, for a simulated predator approach, all I basically did was take a probe, and the buried clam is right here. You can just see the tip of its siphon, this little dark patch right here. I took a metal probe and moved it through the sand until the clam closed up its siphon, or its mouth essentially. And that indicated the point where the clam was no longer, breathing or eating because it had closed up its mouth. And it was hiding from the predator. And then I measured the distance between the probe and the clam when the clam had stopped using its siphon or its mouth. And so what I found overall is that acidified blue crabs did not forage as much. This is foraging time down here on this graph. The acidified crabs are in red, and they spent a lot less time foraging than crabs under more normal conditions. They were lazier. I also found that acidified clams did not respond to approaching predators as quickly, or essentially the approaching probe. And so here, down here in this graph, is the distance between the clam and the probe. For acidified clams, it was quite short, only 10 centimeters. Clams under more normal conditions were responding to that probe from much further away. And so this would be considered more risky behavior, waiting to close up your siphon until the last possible minute to avoid being detected by a predator. So as a result, when the crabs were foraging, they had an easier time finding their prey, probably because the prey didn't really close up their siphon. They were releasing some smells into the water column that the crab was able to detect. They were moving a little bit. Crab was able to detect that, and so acidified clams were encountered more often in those trials than under more normal conditions. And so as a result, there was actually no increase in mortality for the clams, because even though the crabs were better at finding them, they didn't really spend as much time eating. And so they spent about the same amount of time, or they ate about the same amount of clams in the acidified versus non-acidified trials. Crabs are lazier. Clams are experiencing more risky behavior, and it essentially balanced out. How many more slides do I have? Okay, we'll go through these really quick. I'm only going to hold you over for like 2 minutes. So, extreme weather events. Most models agree that climate change is likely to increase the average intensity and rainfall of hurricanes. So we're expecting to see more intense hurricanes. But models aren't as certain about whether the average number of hurricanes will increase. And so while we might expect to see more Category 4s, 5s, and eventually even Category 6s, we may not necessarily, on average, see more hurricanes per season. We're not quite sure. A lot of these storms end up going into the Gulf when we're looking at predicted or projected hurricane paths in these models of the future conditions. A lot of storms end up making their way through to the Gulf. So definitely something to be concerned about here. And then finally, with climate change, we can expect to have more extreme weather events in terms of heat waves and cold spells. Marine heat waves and cold spells can have huge ecological implications, resulting in shifts in species range, local extinction, and economic impacts when they impact aquaculture or other fishery species. In our recent freeze event this spring, a lot of people were reporting seeing the alligators stick their little snouts above the ice so they could continue to breathe. Alligators can only live this way for so long, and so if you have an extreme cold spell, you can experience mortality events for some animals like this. Abnormal cold winters may also be a critical reset button for invasive species, which is quite nice. And so the U.S. mid-Atlantic coast has seen this, where these cold spells remove a lot of green porcelain crabs from their coast, and these porcelain crabs are causing a huge impact in terms of ripping up marsh and eating a lot of critters. So that's been good. A good thing about these extreme climate events, but for the most part, they upset the balance of what's naturally there.